Coming to the third lecture of dihydrogen. This is our lecture number 3. Question is, give preparations of dihydrogen. So we are doing preparation. First is by action of metals on water. 2Na combines with 2 water to give you 2NaOH plus hydrogen. Similarly, 2K combines with 2H2O to give you 2KOH plus hydrogen. Ca combines with 2H2O to produce CaOH twice plus hydrogen. Mg combines with 2 water to give you MgOH twice plus hydrogen. So this is the way how active metals they combine with water to produce dihydrogen gas. Aluminium can also produce hydrogen gas on reaction with 3 water molecules heated. You will get Al2O3 plus 3H2. So these are the action of active metal with water to produce dihydrogen. Then we have the action on metal hydrides. From metal hydrides, 2NaH combines with water will give you 2NaOH plus hydrogen. Similarly, calcium hydride can combine with water to produce calcium hydroxide plus hydrogen. So in this manner, we can produce hydrogen by action of metal hydrides on water. Then we have action of dilute acids on metals. Action of dilute acids on metals. Zinc combines with 2HCl to produce ZnCl2 plus H2. Tin combines with 2HCl to give you SnCl2 plus H2. SnCl2 further combines with 2HCl to give you SnCl4 plus H2. Magnesium combines with H2SO4 to give you MgSO4 plus hydrogen. So these are the reaction of active metals with the inorganic dilute acids. Then we have the action of bases on metals. This also produces the hydrogen. Action of NaOH on metals. Zn plus 2NaOH, Na2 ZnO2 plus hydrogen. Aluminium also combines with NaOH to give you 2NaAlO2 plus hydrogen. So next we have fifth method by electrolysis of water. So when water is electrolyzed, we get 2H2 plus O2. H2 obtained at cathode, O2 is obtained at anode. We have Bosch process, we have already done that. Bosch process, we have done that. Lane's process, discussed. From hydrocarbons, CH4 treated with water at high temperature to give you hydrogen gas. So hydrocarbon when treated with water at at high temperature 1270 Kelvin in the presence of nickel, they produce dihydrogen gas. Similarly, alkane, propane C3H8 plus water, we get 3CO plus 7H2. The mixture of CO and H2, this is termed as water gas. It is also called as syngas since it is used in the synthesis of organic compound. It is prepared from wood, sewage, sawdust and number of other compounds. The process of preparing syngas from the carbon or coke is called as coal gasification. Preparation of syngas from coal, it is called as coal gasification. This is called as coal gasification, and CO and H2 mixture is further treated with water to give you CO. CO2 plus 2H2 is obtained from this. So these are the ways how we prepare dihydrogen. It can be also prepared by the cracking of hydrocarbons. When hydrocarbons are heated in the absence of air at very high temperature, around about 1270 Kelvin, hydrocarbon decompose to give you carbon plus hydrogen gas. So this is also obtained by decomposition of the hydrocarbon gases. Now it is also obtained during electrolysis of NaCl from electrolysis of aqueous NaCl to NaCl plus 2H2O. It is electrolyzed. We get 2NaOH plus H2 plus Cl2. H2 is obtained at cathode, Cl2 at anode. So in this manner we can prepare dihydrogen. Now after doing these preparation of dihydrogen, we come to the next. What are the physical properties of water? So water is a very important compound to us. All of the life on this planet that survives due to water. It is very necessary compound. It is used as a very universal solvent to dissolve all the compounds. It is used in the day-to-day chemistry, in biological reactions, biochemical reactions. So this is our lecture number 5. That is question number 1 of lecture 5. That will be give physical properties of water. What are the physical properties? This is lecture number 3. Continue. What are the physical properties of water? First is it is colorless, odorless, tasteless liquid with freezing point 273 Kelvin, melting point the same, boiling point 373 Kelvin. Water has maximum density at 4 Kelvin because at that state the volume of water is minimum and its mass is maximum. Mass is constant although, but volume will be minimum, so density will be maximum at 277 Kelvin. Water exists in three physical states. It exists as a solid ice, it exists as a water and as a steam. So existence of ice form of water is up to 273 Kelvin and it exists as a liquid between temperature from 0 degree centigrade to 100 degree centigrade, and it exists as a gas above 373 Kelvin. So it exists in the form of liquid from 273 Kelvin to 373 Kelvin or 0 degree centigrade to 100 degree centigrade, and it exists as a gas above 373 Kelvin. Now we come to the next question. Discuss chemical properties of water. Action on metals. We have just saw the action of metals on water where hydrogen gas is produced. Action on non-metals. It combines with non-metals like nitrogen, hydrogen and produces their compounds. Action on non-metals. This is done in preparation of hydrogen. Non-metals N2 plus 3H2 combine in the ratio of 1:3 in the presence of iron and molybdenum, 200 atmospheric pressure, 773 Kelvin to give you 2NH3. This is action on first non-metal, then it combines with sulfur to give you H2S, high temperature. It combines with carbon under natural condition, or as such it can give you CH4. Reaction with phosphorus, it will give 4PH3. Then we have action on metal oxides. It combines with metal oxides NiO plus H2. You will get Ni plus H2O. Similarly, it can combine with ZNO, hydrogen, Zn plus H2O. So it combines with some of the metal oxides and produces water on reaction with those metal oxides. Now, ammonia, electrical conductivity of water. Pure water is bad conductor of electricity. But presence of impurities in water introduces ionization in water as hydronium ion and OH negative ion, and this conducts in the presence of impurities. It is amphoteric in nature. It can take a proton from other substances, forming hydronium ion and chloride ion. It can supply proton to other Lewis bases, producing NH4 positive ion and OH ion. Here water is acting as a acid, here water is acting as a base. So it can act both acid as well as base. so it acts as a amphiprotic or amphoteric substance. Then we have oxidizing and reducing properties of dihydrogen. So water can behave as both. It can serve as oxidizing agent by taking electron 2H2O, oxidizing character. 2H2O takes up 2 electrons from metals and changes into 2H negative plus hydrogen gas. Then we have reducing character. It can reduce metal into metal hydroxide. Here water is acting as a oxidizing agent. Now we have the reducing character. Action with non-metal, with here water will serve as reducing agent. Four HF will be produced here. If we take 3F2, 3 water will combine with it, we get 6HF plus ozone gas. So this is the reducing action of water when it reacts with the non-metal compounds. Then we have hydrolytic reactions, where metal or non-metal oxides, they combine with hydrogen and produce number of compounds. They produce hydroxides. Hydrolytic reactions. CaO combines with water, giving you CaOH twice. SO2 combines with water to give you H2SO3 sulfurous acid. SO3 combines with water to give you H2SO4. P4O10 combines with water to give you 4H3PO4. Here we will be having 6 water molecules. Phosphoric acid is produced. These reactions are called as hydrolytic reactions of the water. Then we come to next question. Comment upon hydrogen as a fuel and tell about its economy. Comment upon H2 as a fuel and tell about its economy. So hydrogen is a pollution-free fuel. As we know that natural sources of the fuel, they are depleting day by day. Coal, petroleum, natural gases, they are depleting. Therefore researches are on to discover some alternative fuel. Therefore reactants therefore we are seeing hydrogen as a one of the future probable fuel. And this hydrogen, when ignites, releases lot of energy and no pollutants are produced during combustion of hydrogen. So it is used, it is non-poisonous gas and it can be easily obtained by the decomposition of the water. So researches are on to produce hydrogen by decomposition of water and utilize this hydrogen for running vehicles, for running our other electrical equipment. So days not far away when we will be using dihydrogen as a future fuel, and This hydrogen, it has been used as a fuel along with in a mixture of CNG gas, but since the combustibility of hydrogen has not been controlled, and moreover there is a problem in storage of the hydrogen and its transportation due to its highly combustible nature. Therefore, due to this problem, we are not able to use hydrogen as a fuel so early, but they are not far away. We will be controlling this and will use this as a fuel. Then we talk about the hydrogen economy. The basic principles of hydrogen economy lies in its storage as well as in the transportation. 5% mixture of hydrogen and CNG, compressed natural gas, is generally used as a fuel in CNG vehicles. Efforts are on to control its combustion as well as to take the proper storage devices, and we are trying to transport it from one place to another place. So there is not far away to use hydrogen as a future fuel. So hydrogen will be used as a future fuel by us in coming days. So this is regarding hydrogen as a fuel and its economy. In next lecture we will be taking some more compounds, hydrides, and then some other compounds of the hydrogen. Thank you very much.